Welcome to BKSS Academy. I hope you are doing great, my dear students. Now we will discuss about channelization, which will be very much helpful for your different kinds of examinations, like semester examinations, as well as for enhancing your computer knowledge. It is a multiple access method in which the available bandwidth of a line link is shared in time, frequency, and code. This is the This is the definition of the channelization. The total available bandwidth of a link will be shared within time, frequency, and code. These channelization protocols are of three kinds, that is frequency division multiple access, time division multiple access, and code division multiple access. First we will discuss about frequency division multiple access. So frequency division multiple access, the available bandwidth of a common channel is divided into bands. They are separated by guard band. Each band is reserved for a specific station. So one diagram is given here, that is this available bandwidth of a common channel. This is the available bandwidth of the common channel divided into four parts, 1, 2, 3, 4, and each part is reserved for a station, like this diagram. Similarly, TDMA, bandwidth of a channel is time shared between the different stations. The station share the bandwidth of channel in time. Each station is allocated a time slot during which it can send data. Each station transmits its data in its assigned time slot. So diagram is like this. This is the total channel and time slot is given T1, T2, T3, T4, T5, and this T5 time slot is given to a specific station, that is station 5. In between it only the station 5 can send the data. Similarly, station 4 in T4, station 3 in T3, station 2 in T2, station 1 in T1. Another concept is CDMA. So multiple stations can send data at the same time. In this method, one channel carries all transmission simultaneously. The station uses different code to achieve multiple access. CDMA uses sequence of numbers called chips. If code are multiplied with each other, then answer is 0. If codes are multiplied with itself, the result is n. N means number of station. Station 1 has code C1, station 2 has code C2. Code C2. If C1 into C2, it will be 0. If C2 into C2, it will be n, that is 4, because number of stations. So one example is given here. These are the station 1 data D1, station 2 data D2, station 3 data D3, station 4 data D4. Code is C1 for station 1, C2 for station 2, C3 for station 3, C4 for station 4. The transmission will be C1 into D1, C2 into D2, C3 into D3 for station 3, C4 into D4 for station 4. For a single channel, C1 into D1, C2 into D2, C3 into D3, C4 into D4. One exam question is there. Prove that a receiving station can get the data by specific sender if it multiplies the entire data on the channel by sender's code, then divides it by number of stations. So example is just like that. This diagram is like this. station 1, station 2, station 3, station 4, and station 1 is sending the code. Suppose station 2 want to listen what station 1 is telling. So what it will happen? C1 into D1, C2 into D2, C3 into D3, C4 into D4 into C1, because station 2 is wanting to listen what station 1 is sending. So result will be that multiplied by the C1, C1 into D1, total code will be multiplied by the C1. That will be C1 into C1, C2 into C1, C3 into C1, C4 into C1. So all these are 0 because of multiple different multiplication, and this C1 into C1, it will be n, and that is 4, because 4 stations are there. So 4d1 plus 0, these are the 0, all these are 0 because of different codes. So 4d1 as result is 4, then for listening divide with it. 4d1 by 4 is equal to d1, that is the final data sent by the station 1. Thank you.